Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And the idea comes from one of my subscribers. He said, Greg, if there's convective clouds like cumulus clouds, how can you tell whether or not they're going to be non-existent, scattered, broken, or even overcast? Well, scattered and broken are sort of aviation terms for how much of the sky the clouds cover. Scattered is generally thought to be about 10 to 50%, and broken 50 to 90%. Anything over 90% is more or less overcast. Anything less than 10 is virtually clear. And so those are the definitions we're going to be working with today. And these we're going to talk about two different scales in the atmosphere. There's a global scale, and then there's a synoptic scale, which is systems that basically are of a size of 620 miles or more. And then the mesoscale, which is the scale of thunderstorms, anywhere from 6 to 620. But today we're going to be talking about numbers much closer to the 6, individual thunderstorms having a diameter of maybe 5 to 10 miles. So supposing we've got a big ridge sitting over us in the upper atmosphere, and there is large-scale subsidence going on. In other words, the air is sinking over a large scale. So in those types of situations, cumulus clouds, it's like the atmosphere is saying, this is not a favorable environment for you, buddy. You might not even want to try to exist, but a few robust ones will form, and in this case, it would be just scattered cumulus clouds, and they wouldn't take up that much of the sky, and they certainly wouldn't produce any rain. And then sometimes you'll get what's called a mid-level cap, which is abnormally warm air in the mid-levels of the atmosphere, and the air parcels try to rise, and they get into that warm air, and they say, uh-oh, I'm no longer warmer than my environment. I'm cooler than my environment. I'm negatively buoyant, and so I am going to sink and go back where I came from. And so in those types of situations, it stays clear. You don't even get the formation of clouds. And this happens a lot out in the plains, where warm air will come in off the Rockies. Obviously the mountain surface heats up more than the air on either side of it, and that warm air moves out over the plains. And so it's very hot and humid, but there's not a cloud in the sky because of this mid-level cap. And then if something comes along to remove that cap, all heck breaks loose, and you can go from clear skies to a tornado in 45 minutes. So it's almost like an overinflated tire. All that energy is building up, and then somebody pricks it, and bang, all heck breaks loose. So in this type of scenario with a mid-level cap, the clouds don't even get going at all. Now, sometimes you can have an inversion at the top of the boundary layer. Now, we've talked about the boundary layer before, but it's basically the part of the atmosphere that is influenced by the ground. Okay, so when the sun heats the ground, it heats the air above it, and then convection carries that heat upwards. And the depth at which the atmosphere is mixed, well mixed, is called the boundary layer. So what if you have an inversion at the top of the boundary layer? Well, what happens in those types of situations is that the clouds develop, but then they run into this inversion and they spread out across the sky. And this is what I've referred to in the past as the atmosphere being in its self-destruct mode, where you get heating, and then all of a sudden the clouds form, and because of the inversion they spread out, and many times that can get to be a broken to overcast situation. And we call those stratocumulus clouds because they're more or less flat. They don't really have a lot of vertical development to them. And then finally, I wanted to talk about something called the convective condensation level. And this is determined by how far apart the temperature and the dew point are. If they're, 30 degrees apart, it may take a long time for cumulus clouds to develop. But if they're only 15 degrees apart, it won't take much time at all. And in those types of situations, if it's really, really hot and humid and there's no inversion and no mid-level cap, then you'll get towering cumulus clouds all over the place, and they'll develop fairly early in the day. And in those types of situations, usually the cloud cover is at least broken, and in some situations could even become overcast if the thunderstorms really get going. So those are some of the different scenarios that lead to different amounts of cloud cover in the sky when you're dealing with convective clouds. There are the credits. That is the bonus weather video. Hope that made sense. Number 2 for this week. Number 3 coming up Friday. Next daily weather update coming up tomorrow. Remember, a severe thunderstorm watch in effect until 8 o'clock this evening for all counties just south of the Triangle area. Damaging straight line winds and or hail are a possibility, so be on the outlook for that. You all take care, folks, and we'll talk to you soon.